I'm Michaela Parker, founder and executive director of the Academic Data Science Alliance, and I'm here to welcome you to our next installment of Data Science Conversations, where we'll hear from the University of Michigan and the University of Washington. But first, I was going to tell you just a little bit about the Academic Data Science Alliance for any of those of you who are new to our community. We are a group of data science researchers and educators who take responsibility for a just, equitable future where data science approaches are thoughtfully applied in all domains for the benefit of all. Now on this slide in the corner, there's a QR code, and that'll also appear on the subsequent slides. You can go ahead and snap that. That'll take you to our website where you can learn more about our activities, events, our mission, vision, values, and how to become a member. With that, I want to thank you all for joining us. And now I'm going to introduce our moderator for today, Andreas Berlind. Andreas is a professor of physics and astronomy at Vanderbilt University, where he also founded and continues to co-direct the Data Science Institute there. He is actually now transitioning to a new job as program director at NSF, where he'll be working on astronomy and data science related programs. Andreas, why don't you take over?
So I'm very happy to moderate this discussion. Today we're very excited to have leaders from two of the longest running data science institutes in the US, the University of Washington's eScience Institute, and the Michigan Institutes for Data Science, otherwise known as MIDAS. From Michigan, we have Dr. Jing Liu, who is the managing director of MIDAS. Jing is currently interested in examining the data science research infrastructure and data science reproducibility, and in using data science to support public policy. And we also have Dr. H.V. Jagadish, who's the director of MIDAS and is a professor of computer science at Michigan. Before joining Michigan's faculty, he was the head of database research at AT&T Labs. His research area is in data management, and he's also developed a popular course on data science ethics. So Jing will give us a short presentation on MIDAS, and then Jag will join us for the panel discussion later. From the University of Washington, we have Dr. Sarah Stone, who's the executive director of the eScience Institute. And she also directs the University of Washington Data Science for Social Good program that connects students from across the country with projects in academia, government, and the private sector, with the goal of finding data science solutions to pressing societal challenges. And finally, we also have Dr. Andy Connolly, who's the director of the eScience Institute and a professor of astronomy, and the associate vice provost for data science at University of Washington. Andy's research focuses on how best to exploit the massive volume of data that's going to come from the next generation of astronomical surveys. As with Michigan, Sarah will give a short presentation on the eScience Institute, and then Andy will join us for the panel discussion. So with that, I'll hand it off to Jing for her presentation.
I'm very happy here today to share a little bit of updates of our work at MIDAS. I will start though by giving you a little bit of a context. So as you can see on this slide, our mission is really about both the scientific and the societal impact of data science and AI research at the University of Michigan. As you're all probably aware, data science institutes can come in many shapes and forms. The two institutes that are featured today are both research organizations. So at MIDAS, our work really revolves around research. Our training and collaboration efforts also revolves around research, building research capacity, bringing in research resources, and maximizing research impacts. I want to mention that we don't offer degree programs in data science. Those are offered by traditional academic units on campus. Our community has about 430 faculty affiliates from all the schools and colleges on Ann Arbor campus and Dearborn and Flint campuses. So in other words, scientifically, we're a very diverse community. Our students do participate in our research, training, and community building programs. We have a very small core team, which means that we rely heavily on collaboration with faculty affiliates to carry out our research programs. So the first highlight I want to mention today is our effort to enable ethical data science and AI research on the campus. Aside from standard approaches such as supporting such research through pilot funding program and our postdoc program, and also bringing in prominent researchers to campus for discussion and dialogue. I want to mention an NSF-funded project led by JAG to build a system to adjust for data bias. And this is a project in collaboration with NYU and also with UW. I also want to mention a fun project that I'm leading called White Cube Black Box, which illustrates the biases both in face detection algorithms and also in the practices of museum artwork acquisition, which is currently on exhibit at the university's Museum of Art. We also have invested a significant amount of effort to enable reproducible data science and AI research. So through 2 rounds of reproducibility challenges, we collected good practices and tools from our researchers. And through reproducibility showcase series and also an online collection of tools, we're connecting researchers with tools to improve the reproducibility of their research. In the future, ideally, we would like to be able to offer training and consultation, and also be able to refine the tools and enable their adoption. So, but the bulk of our work really is about enabling groundbreaking research, especially highly interdisciplinary research. So these are done through informal work and also through formal programs such as pilot funding, managing dataset access, and also research incubation events in response to major funding calls, and also on particular research themes such as sensor data analytics, mitigating missing data in COVID research, and biology-inspired math theories. So in the past 6 years, Midas has directly enabled more than 100 grant awards with the dollar amounts totaling more than 100 million. We are also the front door for the university's data science and AI collaboration with academia, industry, and the public sector. So in the past couple of years, we've been collaborating with more than 50 external organizations each year. I want to just mention 2 things here. One is our annual Future Leader Summit, which is an event for PhD students and postdocs to promote their careers and also to promote interaction among data science institutes. So each year we have participants from more than 30 universities, and more than half of our participants have been women and underrepresented minorities. So the theme of the next event is responsible data science and AI. In a minute, I will put a link of our event in the chat if you guys are interested. We're still in the process of seeking nominations. Midas also organizes a number of data for social good projects for both of our faculty, researchers, and our students. So I want to mention 2 that are ongoing. One is a data analytics project to support Detroit's digital inclusion initiative. And another is to build education databases for Native American tribal nations in the state of Michigan. So with this, I think I conclude my updates. Thank you.
And so now we'll hear from Sarah about the eScience Institute.
It's our pleasure to have the opportunity to speak with you today, and really special thanks to ADSA for finding a way to support these conversations that we had all hoped were going to happen in Savannah last November. My brief talk today will focus on the approach that we've taken to data science at the University of Washington, which is highly integrative and interdisciplinary, and has informed the creation and evolution of the eScience Institute. As early as 2007, the UW had visionary leadership, including eScience founding director Ed Lazowska, who recognized really the tremendous and transformative potential for data science, not just in the development of cutting edge tools and technologies, but also in the application of these tools and technologies in kind of the broadest imaginable range of fields. Important benchmarks in the development of our institute included the Moore Sloan Data Science Environment Award and funding from the Washington Research Foundation. Based on the unique research programs and support that were created in the context of those awards and that are provided to university researchers, the UW Provost now provides a portion of permanent funding to support the Institute. So our mission really is very broad and is focused on empowering researchers across all fields to answer fundamental questions through the use of large, complex, and noisy data. And we're also really interested in engaging in all parts of the data science workflow. We've created a physical and also, of course, now virtual hub for data science activities and programming on campus, and lead a community of innovators in the techniques, technologies, and best practices of data science. Just a quick peek, remember when we all had spaces and we went to them? We have a space that's historically been very important for us in kind of overhearing each other's conversations, forging new partnerships, supporting training and workshop activities, and providing a neutral space on campus for data science to flourish. The backbone of the eScience Institute really is our research staff, who are unique data and research scientists, all of whom maintain individual independent research programs, as well as supporting all the activities and programs of the Institute. As you can see from the diversity of backgrounds and disciplines listed here, they really bring a wealth of technical experience and expertise to our team. Broadly speaking, our goals and activities align in 3 areas, typical to many institutes and universities. So around education, research, and community building. And I'll touch on some of our activities in each of these spaces briefly. In terms of our role in the development of a formal data science curriculum at UW, the eScience, back in 2013, we convened a data science education working group that aligned around the shared goals of educating all UW students in data science and integrating data science into existing departments on campus, with the idea that students graduate with the data science skills that are most appropriate for their disciplinary field, and that data science was not viewed on our campus as a separate department, division, or school. Last fall, we were integral to the launch of a data science minor, which is targeted to students outside of STEM and creates various pathways through the minor to support a mixture of data science skills and data science studies coursework. Much of what we do in terms of data science support happens through informal education programs, such as all of the research staff that I showed you previously hold open office hours. We lead technical workshops such as software carpentry, trainings in sort of Cloud 101, initiating researchers into working in the cloud. And then also we've evolved disciplinary hack weeks across many different spaces, some of which are listed here on this slide. The idea of the Hack Week model is that this has really emerged within the data science community as a powerful tool for fostering the exchange of ideas in research and computation. In contrast to conventional workshops or conferences, Hack Weeks are really intensive and interactive. They're facilitated by 3 core components. There's tutorials and state-of-the-art methodology, peer learning activities, and then on-site project work in a very collaborative, inclusive environment. This setup has proved so powerful, and we've had such great experiences running Hack Weeks over the past 7 years that we have as an institute have recently rolled out a Hack Weeks as a service program. And so we're working with various groups in this coming year to offer new and exciting Hack Weeks. I want to wrap up by talking about a couple of our kind of quarter-long research programs. The first of which is the Data Science Incubator Program, which has supported 54 projects across 30 different departments over the past 7 years. These projects involve a one-on-one collaboration between one of our eScience data scientists and a researcher, often a graduate student or a postdoc, but occasionally a faculty member. And these are to work on tractable data science challenges related to their research. This 10-week-long program often leads to publications, grant proposals, and long-term collaborations. The second program that I wanted to bring up is, which has been offered each summer since 2015, is the UW Data Science for Social Good program. This program brings together data scientists and domain researchers to work on focused collaborative projects for societal benefit. We support compelling, timely, publicly relevant projects that are poised to take advantage of this sort of tremendous student talent and the computational resources associated. I just wanted to really highlight to this group that we just opened our call for project proposals for 2022. And that includes, so that the call for project proposals, so we take proposals from organizations across the country, both within academia as well as public agencies and nonprofits. And we also just opened our call for student fellows, which is open to upper division undergraduates and graduate students from universities across the country. We've only been able to show you a sliver about our institute, so I wanted to end up by saying that we're fortunate to be engaged in a number of ongoing projects and collaborations, both within UW and more broadly, and we look forward to using the rest of this time today to have the opportunity to discuss these and many other topics with you all. So thank you for your attention and looking forward to having some discussion.
If you're in the audience and you would like me to ask a question for you, please just put it in the chat and I will try to get to it. So the first question is kind of general, and I'd like to sort of step back and look at the evolution arc of data science on your campuses. So especially since you've been around for a long time. So can you tell us sort of what are the broad strokes of how data science has evolved on your campus, and also in the future, how do you see it evolving, both sort of institution-wide and with your institute in particular? So I'd love to hear from both institutes, whoever wants to talk. Let's do Michigan first.
All right. So I think that the degree programs are probably the easiest thing to do. And so that's where we started. And unlike many other institutions that started with the master's degrees, we started with the undergraduate degree first. This was a collaboration between our computer science and our statistics departments. And so this was not an institution-wide thing. This was not a Midas thing. This was just a two-party collaboration between two relevant departments that felt between them they had what it took to cover the waterfront. And we also developed a master's degree program. Two other departments joined in for that, our biostatistics and bioinformatics departments that were strong in graduate education. So again, that's just a 4-department degree program. With that as context, when Midas was set up, we were explicitly set up with a research focus. And so we do not do, at least we do not do significant educational programs. We do have what we call a data science certificate, which is very similar to the data science options that Sarah described at Washington. I think that kind of focus has worked for us. In terms of where we are going, one big thing that has happened over the past few years is AI has become a really big buzzword. And there isn't that much difference between AI and data science as far as most disciplines at a university are concerned. So whether they're using AI techniques or data science techniques, one can parse things. And certainly if you're in the trenches and doing the methodology, there are lots of things that one can talk about, what's in the intersection and what's not, etc. But if you're a geologist or a political scientist or a biologist trying to develop something, this is all the same. And in fact, I even get asked questions about what's the difference between data science and computational science, because to many people in their domain, when they do computation, they do it because they're crunching data. And so a thing that we have successfully pivoted at Michigan is that we are the Michigan Institute for Data Science and Artificial Intelligence. And we've very clearly got AI at the campus level as part of our mission. I'm going to stop there, and I'm sure there'll be more discussion.
So maybe I'll take the UW perspective. A lot of the things that Jag was talking about really resonated, I think, with UW. We actually took a slightly different approach from Michigan, and I think there are many different ways to develop and integrate data science across a campus. But we started out at the graduate school, at the graduate level. We started out with a targeted program, which was very much an advanced data science option, which was a collaboration between a number of domain sciences, particularly traditionally STEM fields, with computer science. And it started out with a small cohort of eventually about 20 graduate students. And from that, we learned how to teach data science across not just to the statistics and CS students, but also to the astronomy and oceanography and biology students. And then as that developed, the data science education programs actually started to expand out into the departments themselves. And I think I see that as one of the biggest transitions that has happened over the last 10 years, that for UW, data science has moved from kind of almost a central group of people and has now slowly spread out, initially at the graduate options level in the different departments. And then after that, going into the undergraduate programs. So we very much went from graduate down to undergraduate. And what we're seeing now is the growth of, in some ways, following the models such as those delivered by Berkeley, is expanding out the data science, not just to the STEM fields, but in the development of a new data science minor at the University of Washington, having that expanding out into non-traditionally represented data science departments, whether that's digital arts or digital humanities or public health, or really trying to get data science across the whole of the campus. In terms of directions going forward, I agree that the emergence of AI across so many different departments is something that's been quite dramatic over the last couple of years, and is introducing some real challenges associated with how do you integrate AI with the core kind of physical rules that describe, what biological or physical systems, and also the questions of ethics associated with AI, and how do we ensure that students who, just take the astronomy example, students who are working in astronomy, working on AI applications, may not be thinking about the ethical implications of the work that they're doing, yet many of those will go out into industry and society, and their skills will actually have ethical consequences. So educating and teaching about that, I think, is something that's really important. And then in terms of kind of future directions, one of the things that we've noticed, and we did a survey on campus about a year ago, is as we rely more on data science, as institutes emerge at our universities, we're also relying on the development of the software and the software engineering. And so this isn't programming. This is how do you actually build software systems that are robust, that are scalable, where we're depending on these systems for the research results that are coming out. And so one of the things in a survey, we were asking about data science needs, and we also asked about software engineering needs. And we were finding that there were on campus, there were roughly 60 FTEs of effort of people who were needed to support the software engineering side of research. And yet a lot of people were finding real challenges in terms of bringing people in with those skills to be able to architect software solutions, particularly when as a researcher, you have a limited scope and timeline for your research project, or you're only going to want to hire someone in at a fractional of an FTE effort. And so we're seeing that maybe software and software engineering is the way it is where data science was maybe 5 to 10 years ago in terms of beginning to emerge. And what we're looking for is how do you build up the educational resources to make sure that if we're so reliant on data science and reliant on software, how do we make sure that the software that we're actually developing can be shared, can be robust, and we can actually believe the results that are coming from it?
I want to add anything?
Let me just kind of follow up on what Andy said at the last bit. One of the trends obviously is that so many people are adopting data science methodology, AI methodology to their own research, and new methodologies are coming out so quickly, right? So one question to keep in mind is how do we help people focus on the fundamental research questions instead of just being, I would say, being overwhelmed by the available tools possible. And so how to do the best science with the most appropriate tools.
So there's a question. Go ahead. Yeah, sorry, Sarah.
Oh, I was just going to say quickly, that really resonates with us too. And the incubator program that we mentioned, we get a dramatic number of projects that are focused on machine learning. And in many cases, it's kind of, they just want to use that new tool, but it's not clear that it's really appropriate for the work that they're doing, or that it's, I guess, and that there isn't, there aren't other more appropriate tools given what the research question is based on. So that's certainly something that we see too and get interest from the broad community, and because it's kind of a hot place to be working.
So there's a follow-up question in the chat from David Monjo, I think that's how it's pronounced, who says, very interesting to hear Jag's take on AI versus data science for most domain scientists and practitioners. The NSF and other federal funding agencies certainly seem more enamored with AI than data science broadly. If the same, why do folks think that so many universities have both data science institutes and AI institutes or centers?
So I think that from the methodology perspective, if what one is trying to do is develop new data science methods or AI methods, there is sufficient difference that it makes sense. And I think that a lot of, for instance, NSF funding is for pushing the frontiers there. And I think that if that's what one is trying to do, one has structures to do it. And in the case of AI, they're usually, most universities have AI as a part of computer science, and there might actually be a defined AI group of some sort, a lab or some sub-departmental entity in many cases, depending on the size of the CS group. And so this kind of thing, I think, makes sense and is sort of a natural growth from where everybody is. Most places, before there were data science institutes and centers, didn't have something called data science. And so there is, at least from a labeling perspective, the need to create something that owns that label. I think that there is a significant issue of whether a university institute is being driven by the domains, or if that's sort of, I'm going to call that in a crude way, I'm going to call it the primary function, though that's really not an accurate statement. Just to distinguish it from the other end of the spectrum where the goal is push the boundaries of methodological advance. And if you look at, obviously everybody wants to do everything, but if you look at how resources are invested in what really institutes are trying to do, I think that there are many universities where the goal of setting up these centers is to boost a department or two that is really focused on the techniques of these disciplines. That's not the case for us at Michigan, and my understanding is that's not the case for UW. And if what we're trying to do is to serve the university broadly, I really don't see room for having a data science and an AI institute as two separate entities. There's just, they're basically doing the same thing.
I think the centers that are developing at the University of Washington, particularly the ones that are emerging from NSF and DOE and NASA and NIH driven funding, tend to be very targeted at specific either methodological advances, whether it's physics-inspired AI or targeted towards specific domain areas. And I think having those targeted centers is actually a benefit to the universities, and it's also a benefit to the research communities as a whole to actually start investing in, for example, methodological advances that are specific for some of the science challenges. For instance, the importance of uncertainty quantification in a lot of the physical sciences, and where I see kind of the data science centers, both in thinking of it in terms of Midas and eScience Institute, is if you just have these individual AI focused groups on campus, the natural way that they evolve is they remain targeted either within their own specific field, or they remain targeted at a specific type of methodology. And so I think the advantage of having data science institutes is the ability to enable those groups to communicate and to foster collaborations across within those groups, and also to foster collaborations between those groups and other researchers outside of the campus that they're working. And I think it provides this a multiplying effect on campus. And I think we've seen that a lot from very early on with eScience Institute, that what really drove the creation of the Institute was this ground up collaboration, this recognition that researchers from different fields needed to collaborate, needed to share ideas in order for the science to actually progress more rapidly. And I think we've seen a lot of those collaborations be very successful on the UW campus. And so as we're seeing these, whether it's harnessing the data revolution centers emerging, I think that having an institute that is kind of can help this collaborative effort is actually going to become much more important going forward.
Kind of like a convening role, really.
Yeah, communication role. I think the ability to get people to talk. It's very easy to become very stovepiped in terms of you have things that you have to deliver. You have to ensure that you're making progress. Learning from someone else and learning from others and sharing your ideas with others is, I think this has always really been a hallmark of the way UW works. And I think having organizations that help to foster that collaboration is really critical.
So yeah, I mean, I think that's really important, and is exactly what I want to ask about next. You know, we talk in data science about the value of interdisciplinary collaboration, and we all want to do it, and our administration wants us to do it, because, you know, you can get real transformative work if you get people from different backgrounds working together. But the truth is, it's not easy. I mean, it's not easy to do. You know, people can sort of have the water cooler moment where they chat in the hallway, but that doesn't mean that something great will come of that. And that's because, you know, we're all busy with our disciplinary work, and we have those demands. We don't often speak the same language with each other. So there are a lot of barriers. And so my question is, it seems like you've done a pretty good job of fostering these collaborations. So what's the secret? How do you foster and support interdisciplinary research collaborations? You've talked a little bit about your incubators, but maybe we can hear a little bit more about them and how you get people to participate in these things. And then I have some follow-up questions about moving forward. So let's start with maybe Sarah. Maybe you can talk about UW a little bit.
Well, I guess I'd start off by saying I think the University of Washington does a really good, sets a really good stage for fostering collaboration of faculty across different units. And I don't know, Andy could probably comment on this too, relative to other university structures I've been in. That collaboration happens much more readily, and faculty seem much more interested in forging those types of collaborations. So I think there's something to be said just for that, for landing an institute and a university that really moves a lot in that space. I think I would also say, in terms of fostering those collaborations, I think that we've built up a number of programs sort of in those spaces. In fact, that's one of the Hack Week programs that we mentioned can really help to build communities and foster collaborations, bringing people together both around in a disciplinary space, and then also we've actually done this in collaboration with the Berkeley Institute of Data Science, where we've been involved in workshops that bring researchers together around a technical challenge space. So there was a series of workshops, XD workshops, that were focused, for instance, on image analysis. And so there'd be an image XD, and that would bring researchers together around the technical challenge. And I think that's where we all find a really rich and unique space for these institutes, is focusing on the technical challenges that are common across very different disciplinary application spaces. And so I think across many of the things we do, that's how we're structuring our interactions. And we have special interest groups similarly, for example, around using text as data. And that we try and occupy spaces and special interest groups that aren't already happening other places on campus. And I think that's kind of where we can uniquely sit. And Andy, please, I want to add to that.
I just say a couple of things. One is, I think things have changed a lot over the last few years, in the sense that at the early collaborations that I worked in, that kind of brought together CS and astronomy, it took a significant amount of time to learn the language that each other spoke. And so you had to invest early on. It was almost like investing a year of effort to really begin to see real benefits from that collaboration. And I think as data science has kind of moved through the campus, we've become a lot more almost multilingual, right, in our abilities to talk to one another. So I think it's a little bit easier now to actually start some of those collaborations. I think so. I just wanted to touch on one of the points that Sarah made that I think is important from the UW perspective. Why is it that UW has why is it good? Why is it easy to collaborate at UW? And I think one of the reasons is that these collaborations aren't driven from the top down. They tend to be driven by researchers who have a need, and people who are developing the methodologies who have an interest in making sure that their methodologies have an impact, whether it's on research or whether it's on society. And I think that's been true in terms of the types of faculty that have been hired at UW for many years. And so that really has helped some of those collaborations to work. I think the other thing that's very important that traditionally we're not particularly good at universities is allowing things to die, right? So allowing things to emerge and then allowing things to research continues at a pace. And sometimes these areas and the special interest groups that Sarah was talking about, sometimes they're no longer as relevant, or the research has moved into a particular field. And so recognizing that and being nimble, and again, that's not really a university strength in general, but I think is a strength that you can have at an institute, being nimble to what is actually coming, what is new, what's interesting, what's coming out, and bringing people together from those areas and getting them to talk and seeing if some collaboration naturally emerges from that without trying to force it too much.
Jing, you want to?
Sure. Okay. Yeah. So I totally agree with what Sarah and Andy already said, and there really is a lot of similarity to the culture at Michigan as well. A lot of energy for collaboration, a lot of appreciation. I just want to add maybe a couple things. One is that actually what Andreas said, everybody is busy, and there is definitely a hurdle for new collaboration. Getting on the same page, talking about the same language, taking the time to understand what's the best way to collaborate. So I think one thing that a place like Midas or eScience can do is to help lower the hurdle. So, so help lower the hurdle and help them see the value. So one example I want to give is, as so many people are hopping on research on COVID or pandemic in general, as a very comprehensive or very diverse research community for data science, we can convene not only just epidemiologists and medical experts and biologists and microbiologists, right? We can also convene computer scientists together with them, convene environmental scientists to understand the environmental factors for pathogen spread. We can bring in social scientists on board to understand people's attitude and their effect on pathogen spread, right? This kind of very interdisciplinary team around data science methods, I think is an advantage that we can leverage to show people the value of collaboration. Another thing I want to mention is when we talk about data science collaboration, a lot of people would think that, oh, it's about applying data science methods, right, to an application domain X, Y, and Z. But as Andy was alluding to, it's the other direction is also important, which is how can people improve methodology in being inspired by real world challenges, by research challenges in various domains. I think we should also, we are recognizing it, and we're trying to foster both directions.
So my follow-up question is, given that it does take all this effort to spark collaborations, how has COVID impacted this work, given that we can't be together? Have you found a formula to do this successfully virtually?
Well, you guys let us know if you found a success. I think it's really impacted this kind of collaboration building. It's we've tried many ways. I really don't think we found any effective method. I would say people's will to keep research going is a major motivator for them to still join virtual sessions to build collaboration. So we see, limited success. We see work being pushed forward, but really it's been impacted pretty badly.
On the other hand, there is a silver lining too, in that, being a large university, distances can be large. And if you're collaborating with somebody from a different unit that's across campus, you've got to devote an extra 15, 20 minutes commute time for a meeting. And now that goes away because you're meeting on Zoom. And one thing that we've started to do is, for whenever we have, brainstorming sessions or just putting people together, birds of feather for some topic. Earlier, we needed to have a substantial session, have food, and sort of keep people together for at least a couple, often 3-4 hours, because that's sort of the unit of time. Now it's 1 hour tops. So the nature of it is just different. And I think at least it lowers the barriers to initial contact. I'm not sure that it helps for the next level up beyond that.
Go ahead.
I was just going to say, I really miss the whiteboarding aspects of the collaborations. It felt a little bit funny that in some ways COVID and Zoom, it made it easier for me to collaborate across the continents, right? Because there was, it was just time zones were the challenge, but it made it harder to collaborate within our own campus. We actually we brought in a consultant, Charlie Haley, and maybe Sarah can talk a little bit about that, to help us try to transition some of the events like Hack Weeks to make them work more effectively in a virtual environment. I'm reflecting back on some of the potential benefits of learning how to work or hold meetings in some sort of virtual environment. I think there are, looking forward as we eventually hopefully emerge from this pandemic, I think there's lots of issues about accessibility, about equity in terms of being able to come to these meetings, to be able to have the resources either to travel, to meet in person, or to be able, your kind of personal situation doesn't allow you necessarily to travel. And I think working on mechanisms for how to be more, to be able to work, particularly either remotely or in some sort of hybrid sense, I think does have a lot of opportunities as we move away, as we move out of this pandemic, and maybe we can actually take some of these lessons, and maybe we don't have to travel as much. Maybe we can actually make some of our meetings more accessible. But I'll let Sarah talk a little bit about some of the work we did with the Hack Weeks. I think it was, I was amazed at how well they transitioned.
Yeah, what was really fun is, so as I mentioned, we've been running a number of different Hack Weeks for several years, but we convened a kind of a community of practice of other people who had events coming up, and we're all, this was in 2020, we're all panicking because they all had events on the calendar and were thought of as very in-person types of events, very interactive, and really, necessitating that in-person component. And so we worked with Charlie Haley to convene people both at UW and across other universities who had these events coming up, to try and figure out how we, what to do. And a lot of it was really trying a lot of the technologies that were coming out and seeing what worked. And I would say both across the Hack Weeks, and we also ran the Data Science for Social Good program remotely the last 2 years. I think we've all been surprised at how well most aspects of those programs can work, but I think we're still, maybe as Jing was alluding to, flummoxed by how to get that the water cooler, the coffee break, the sort of informal interactions that we all value so much at meetings like the ADSA meeting, which has really been, that's been one of the great things about the ADSA meeting historically, is just the opportunity to run into each other and have some time to have conversations and chat. So yeah, I guess I'm probably not saying anything too new there. The last thing I would say on that is that the Data Science for Social Good program went so well remotely that this year we're actually looking at doing hybrid program, but not hybrid in that each individual will be hybrid, but we'll have some teams that are fully in person and some teams that are fully remote, because being able to be remote allowed us to really broaden the students who could participate, and also broaden the projects that we could take on, because we could have project leads who were distributed across the country or even around the world if we could figure out the time zones. So yeah. Oh, whiteboarding. Yeah, I see in that whiteboarding, that was the, I would say in DS, we have not figured that out. We have tried Limnu, we've tried giving everybody tablets and tried to get the right pens and the right, and nobody ever uses it. We outfitted all of our participants at great, not a great expense, but a great kind of hassle. And so no, if anybody else knows one, please put it in. I'd love to try something that we could actually get people to use.
All right, we have some good questions in the chat I want to get to before we run out of time. David has another question that I think is really important. He says, Jing mentioned being the quote front door for data science at U of Michigan. Do those leading the various data science degree programs and research centers buy into Midas taking that role, count on it, trust it, etc.? Are there systems in place to funnel those at the front door to Midas? And you can say the same thing about eScience as well, because there are many different pockets of people overlapping what they're doing. How do you as an institute sort of take that role?
Okay.
I think, yeah, go ahead, Jing.
Okay, so David, I just want to let you know that our house has many doors. So, so as everybody agrees, right? Data science is actually very distributed, and that's just the nature of the subject. And so I think it's when I say we're a front door, I think on many occasions we're playing that role, but it doesn't mean that officially we are in that role. And obviously many units also have their ways to build collaboration. But I think because Midas is a central unit for data science, a lot of external organizations do reach out to us first. We don't have a sort of, we don't have, I would say, a formal process to connect these with campus units, but our really a big part of our work is to do that. But it's through many different ways. And how do people get buy-in? It's because if we show them that we bring value to them, we help their research, then they would give us the buy-in. Sorry, Jack, what were you going to say?
Yeah, I think you said everything that I was going to say. The only additional thing I want to say is there is a question of in a distributed environment with distributed decision making, earning the trust of our colleagues who are doing leading other related efforts. And I think we are very cognizant of our role as a primarily tax supported entity that's supposed to serve all of our units. And so we try hard not to compete with them. We don't, in most cases, take any significant cut of revenues that come through us to them. And so there isn't a reason for people to say, hey, I don't want you around because you're going to steal my X.
In the interest of time, I'm going to cut that off there and give you, Sarah and Andy, a different question, which I think relates well to what you're doing, which is from Pamela Reynolds about staff data scientists. And I know you have a team of staff data scientists. They seem pivotal for providing consistent and agile expertise to support interdisciplinary teams and training efforts. I'm curious if you have thoughts on recruiting, retaining, and supporting, funding and otherwise, these unique roles at your institutes. And I'll add, given that they can be snatched up by industry at much higher pay.
Do you want to go first, Sarah? No, jump in.
I can go first, and then why don't you add?
Yeah.
I can address the I think particularly how do you retain them? Because I think that speaks to like the way that the positions are structured. And we have two sort of flavors of positions at eScience, which was indicated on that slide and maybe seemed confusing. We have positions that are hired through eScience Institute and are fully funded and full-time positions at eScience, and that's what we call sort of data scientists. But even for those positions that are fully supported by eScience, those researchers typically spend about 50% of their time continuing to do their own independent research. And so all of them have their own research programs, and over time, because most of them have been with us for 4 or 5 years or more, they've started to bring in their own research grants, and to be able to start offsetting some of the funding, for their salaries. But that takes a while to build up. But that makes those positions prestigious because they have research independence. And I think it says a lot that we've been able to keep people in those positions for as long as we have, given that we're located in Seattle and there's plenty of very high paying positions out there. And secondly, just to, I guess, the research scientist positions are positions that are people who've been hired through other units on campus. Also, they have their own independent research programs, but they spend some of their time supporting eScience. And that combination has worked really well to allow us to have a real diversity of research staff, both from a disciplinary perspective, but also in terms of their data science backgrounds and the communities and departments that they bring into eScience with them. And Andy, I don't know if you want to talk about recruitment, since we're thinking about that right now.
I think the current climate, it is hard to recruit. I think one of the other aspects that makes the positions different from industry is that our data scientists and research scientists play decision maker roles in all aspects of our programs. So we don't say here's the data scientists and they're available as a service to you. We say here are a range of projects that people want to do, and our data scientists and research scientists choose the projects that they're interested in and that they feel are impactful for them. And I think that's really important, very different environment than working in industry. And I think maybe that's one of the reasons why, coupled with their ability to do their own research, we have been quite successful. I think one of the big challenges we face going forward is the career progression aspects of data scientists, to make sure that there is the ability for all of our data scientists to progress in terms of their responsibilities and their ability to build groups. And I think this is something that we're thinking about a lot at the moment. Some of our data scientists have moved into the research faculty positions. Some people have moved into, have the ability to move into faculty positions as well. And so there's a range of different career paths, and so being, again, agile and nimble about how people can move and what they think their career projections, what is meaningful to them, I think is important. And that's very much individualized. I think one thing that would benefit us as a academic community would be to start to break down some of these somewhat artificial barriers between industry and academia, so that someone from industry can move back into academia. And we've had that happen for a couple of people, and maybe they move back into academia for a couple of years and then they move back into industry. So if we could stop this idea that once you leave academia, you can never come back in, and allow this a much more of a porous transition, porous transition of people in and out of industry. And I think this sort of thing happens more in the computer science fields, because they've recognized that you can be computer science faculty, you start up a company, and then you come back to being faculty. And I think if we could do that more in the research domains, recognizing that people have the right skills that we need and allowing them to move in and out, I think that might provide more of a way for people to feel satisfied and engaged in their research. Because I can imagine you could go and work for Google for a number of years and then decide that what you'd really like to do is to bring those skills back and maybe apply them to COVID or apply them to biology or chemical engineering or some other area. And maybe after a few years, you transition back into industry after that.
So I know we're past the end point, but I do want to close out with one more question that I'm interested in hearing the answer to, if that's okay. This is for all of you. So the general question is what is the biggest challenge for your programs in the near future? And in particular, one question that's interesting to me is whether you see the role of university-wide data science institutes diminishing in the future as departments and researchers incorporate data science into their own disciplines and curricula, or will there always be a need for this? Who wants to go first?
I spoke last, so I shouldn't speak now.
You can ignore the second question and just talk about challenges for your student in the future.
I'll say a couple of things. I think universities are traditionally not nimble, right? And I think I mean the transition and the rationale is that if you want to teach in a new area, you have to bring in the faculty who can actually teach in that area. And you have to bring in people who are interested in the research in that area. And so it takes time to build up different groups. And I think one of the real benefits of having a data science institute is being able to recognize what are the trends, right? So as Jag talked about, the emergence of AI, right? The emergence of software engineering, the need to start addressing the ethical aspects of AI. How do you do scalable science? How do you teach students more than just the intro to data engineering and data science and programming and statistics and computer science? And how do you start targeting some of the more kind of the next level of education? And I think so having institutes that remain nimble, who have people who have the research scientists and the data scientists on staff who have the ability to move into those areas and help guide the university, I think is, it drives towards a very kind of long-term view of data science and AI and CS type institutes on campus. So I actually think there's a great road ahead for Midas and eScience and many of the other data science institutes.
Yeah, I agree. I think that we're still early in this transition, adoption of data science methods across disciplines. You know, some disciplines, I think there's greater adoption than others, but we still have a long ways to go. And so I think that we'll continue for the next several decades to have a role to play just in terms of helping people adopt this and make greater progress in their domains through the use of data science. But one thing to look at is an exemplar for a similar sort of thing is in the adoption of simulation as a research technique and the computational science field that has grown with that. I don't think that it is the same size of change or the same breadth of applicability as data science. So data science, I think, has a lot more going for it. But today, there are many, many disciplines where there are people who would define themselves as disciplinary experts in their discipline, who just happen to be experts in computational techniques that they apply to solve whatever challenges. And there is a similarity of work across disciplines, and there is therefore a need for a cross-disciplinary computational science sharing of best practices and so on. It's not so much about collaboration across disciplines or bringing a methodologist to work with a domain scientist in the kind of language that we've been using. And I see that sort of thing as an end goal, which I don't think we're going to reach until well after I've retired.
So I want to add to this a little bit. I think another factor to consider is actually the model of academic research itself is fast changing. And I think astronomy might be a good example, right? And suddenly people are changing from doing their own data collection to getting federated data. And this is happening in so many domains, right? The data source is not from their lab anymore. It's from large research consortia from industry and from government. And so through all these, I think it's not only, so universities are not nimble, but places like Midas and eScience can be nimble. So how can we help people adjust to the new model? I think there's a lot of work to be done there as well.
Yeah, I really agree with you, Jing. And I think there's this neutrality, this neutral space that we can occupy allows us to be a lot more flexible and nimble, as you're pointing out, and to reach parts of the community that might not respond if we were coming from, computer science or, a particular department, because we can be seen as kind of a broker or conversation starter. And I guess I would just add to that to say, I think, in terms of challenge areas, we continue to be very interested in trying to reach all parts of campus. And I think the arts and humanities have been a part of our campus that we recognize that we haven't done as good a job of really being integrated with or understanding the needs. And that's something we're actively and have been actively working on. But I think that's something that we will continue to work towards. And I think the data science minor has started to address that on in the student realm, but also thinking how we can better support arts and humanities researchers and collaborate on projects within eScience.
Well, thank you so much. We're definitely past our ending point, so I'd like to wrap this up now. If anyone, there are a couple more questions in the chat. If you want to just stick around, maybe some of the panelists might stick around too, and you can ask them your questions. Other than that, I'd like to thank all four of you very much. Steve, I'm passing it to you.
Great, thank you. And thank you all for coming today. This is, it's been a great conversation. I want to remind everybody that we have these virtual sessions continuing weekly up until the beginning of March. So next week we have a conversation with New Jersey Institute of Technology and University of Arizona. But take a look at the Add to Virtual Meeting page on our website to see what else is coming up. And we look forward to seeing you soon. Thank you all.